Okay, today we're looking at section 4.1 and we're looking at how do you graph quadratic functions that are in standard form. Okay, so first question is, what is a quadratic function? Quadratic function has an x squared term in it. And their graphs are the shape of a parabola. You should have heard of that term before, but a parabola is a curved graph that looks something like this. It could open down, but you've seen that before. So standard form is what we're specifically looking at today. A quadratic function in standard form is in this form right here, ax squared plus bx plus c, where a, b, and c are just numbers. Okay. The parent function for this graph, which is the simplest function in this family, is y equals x squared, or if it's in function notation, f of x equals x squared. That's what it looks like here. Here's the table of values. Remember, if I square a negative, it becomes a positive. So if I square each of these terms, this is what I get as a result, and this is the plot of that graph. So we're looking at graphing these. Okay, so let's just start simple, and let's graph y equals 2x squared. Now there's two different possibilities. If we have a function that's in standard form, but it doesn't have the bx and the c part, it's still in standard form, just the b and the c are basically zero, is what that means. Okay, so if I have that situation, I'm going to graph these by simply making a table, kind of like I did right here. Okay, so let's just make a table of inputs and outputs, and I'm going to go from, you need negative and positive values centered around 0, because anytime we don't have the bx and or the c part, it's going to be a parabola that's centered, the line of symmetry is the y-axis. Okay, so let's go from -2 to 2. Okay, so plugging this in, I got to square first. Remember, our order of operations, square and then multiply. So -2 squared is 4, 4 times 2 is 8. -1 squared is 1, times 2 is 2. 0 squared is 0. 1, I'm going to get 2. 2, I'm going to get 8. Your table should look symmetric on these types of graphs. So let's plot that. One thing you notice is that parabolas are always symmetric about their line of symmetry. Okay, so that would be y equals 2x squared. Now notice this graph compared to this graph, what's the difference? This one appears to be stretched. Okay, it's a little bit skinnier and the values are stretched. If I was to graph this one, it would not be as stretched. That's because of the 2 there. Okay, let's graph another one. -1/2 x squared plus 2. Okay, so again, if I don't have the bx part, if b is 0, my parabola is going to be symmetric about the y-axis. I'm going to simply make a table. Let's make it over here out of the way. Now when I choose the input values for this one, I'm going to use -4, -2, 0, 2, and 4. The reason to do that is because of this 1/2. If I use even numbers and square and multiply by 1/2, I'm not going to have any fractions. If I use 1, I'm going to have fractions. So let's plug these values in. -2 squared is, or -4 squared is 16. Half of 16 is 8, so that's -8 plus 2 is -6. Okay, -2. -2 squared is 4. Times -1/2 is -2. Plus 2 is 0. Remember our order of operations. We've got to square and then multiply by that value. So 0 is going to give me 0 here, plus 2 is 2. This should give me the same values as this. So 2 squared is 4. Negative a half times 4 is negative 2 plus 2 is 0. This will give me negative 6. So let's see. Negative 2, 0, 0, 2. This graph is going to look like this. Now this one opens down because of the negative a value, just like some of our other graphs we've seen with the absolute value. And if you look at it, it's a little bit what's called compressed. It's wider than this one. Okay, and that's because of the fraction here. Okay, so that's how we graph these types of functions if they're missing the combination of bx plus c, or if they're just missing the middle part of the term there. Okay, what if we have a function that has everything? It's in standard form. Then we have to follow a little bit of a process. And that process is in your textbook on page 237, but it's also written right here. Okay, so if we're graphing ax squared plus bx plus c, we have to follow this 4-step process. Okay, first step is to find the vertex. You find the vertex by taking the fraction of the opposite of b divided by 2a. That's the x-coordinate of the vertex. It's also the line of symmetry. Okay, so these graphs are not centered on the y-axis. They're shifted left or right. This will help us find out where they're shifted. Okay, once we find that x-coordinate of the vertex, we substitute that into the equation to find the y-coordinate of the vertex. That gives us our vertex. Okay, step 3, plot the y-intercept. If I substitute 0 into this function, that's going to automatically make these first two terms 0 because x is 0. So then I'm going to get whatever c is. So 0c is my y-intercept. I know where the vertex already is, and that's my line of symmetry. So I can plot this point and then reflect it about the line of symmetry, and then I have 2 points. Okay, and then I finally find one more point and reflect that. So I'll go through an example here, and we'll see how that works. Go x squared minus 2x minus 1. Okay, so in this case, a is the coefficient of the x squared. If there's no number there, we know it's 1. B is the coefficient of the x, it's negative 2. C is the constant term, and that's negative 1. Okay, so step 1 is find the x-coordinate of the vertex. Opposite of b over 2a. So negative 2, which is going to become 2 over 2 times a. So that's going to be 2 over 2, which is 1. Okay, so I'm going to start my graph over here. So the line of symmetry is at 1. So I'm going to draw that dashed line right now. That's where the center of the parabola is. My vertex is on that line somewhere. We know the x-coordinate is 1. We find the y-coordinate now, second step, by substituting 1 into the equation. Got 1 squared minus 2 times 1 minus 1. So I've got 1 minus 2 minus 1. I believe that is negative 2. So combining those, I have my vertex, which is 1, negative 2. So there's my, plot my point there. I'll label that 2. Okay. Step 2 done. Step 3, plot the y-intercept, 0c. 0c is negative 1. So 0, negative 1 is another point. Okay. Because a parabola is symmetric, I can reflect that point over to this side, and I have a third point, which is 2, negative 1. Now technically, 3 points are enough to look at and see a sketch of my parabola. But it would be useful to be able to find one more point, reflect it to have a total of 5 points. So what I would do then is make a simple little table and choose one more value to plug in for x. Okay, so what you want to do is plug in a point that's near these points. So maybe 3, maybe negative 1, one of those points. So let's just substitute 3 in there. So if I substitute 3 into the equation, I'll get 3 squared. 2 times 3 minus 1, so that's 9 minus 6 minus 1 is 2. So 3, 2 is on my graph. And I reflect that over the other side. So you can count two points to the line of symmetry and then 2 over. So this point is on my graph, which is negative 1, 2. Now I have 5 points. You can clearly see where that parabola goes. Like that. Okay? Let's do one more example. This one's going to be a little more difficult because of the numbers we get, but I want to do one like that just so you see it. So let's go negative 1/3 x squared minus 5x plus 2. Okay? Now, what do we know about this graph just by looking at it? My a is negative 1/3. My b is negative 5. And my c is 2. Because a is negative 1/3, we should know that my parabola opens down. And we know it's compressed because it's a fraction there. Okay, so let's find the x-coordinate of the vertex, step 1. Opposite of b over 2a. b is negative 5, so negative 5 is going to be 5 over 2 times a, which is negative 1/3. Okay, so now we got 5 over negative 2/3. How do I divide by 2/3? It's the same as 5 times negative 3/2, the reciprocal, right? Which is negative 15/2, which is negative 7.5 or 7.5. Okay, so that's not the nicest point, but that's what it is. Let's find our y-coordinate. Now we substitute that back in for x. 1/3 times negative 7.5 squared minus 5 times negative 7.5 plus 2. Okay, you might want to refer to a calculator, plug those values in. We should get 20.75. Okay, so combining those, that's my vertex, negative 7.5 and 20.75. Okay, so I better start plotting this. I'm going to make this graph a little bit bigger, just because I know it's going to take up a little room here. Actually, slide that over a little bit, because I know I have to go into the negatives here. Okay, so I'm going to go by 2's just because of these larger numbers. Okay, and then actually let's just go by 1's on the x and 2's in the y. Okay, so negative 1. 10 there. So where's negative 7.5 is halfway between 7 and 8, so I'm going to draw my line of symmetry. I think I might be in trouble here because I got to go all the way up to 20. So here's 20. Here's 22. 22. So 20.75 is way up here somewhere. So it's not as exact, so we better label that point. Well, I've got it labeled here. We know it opens down. Now, next step is to plot my y-intercept, 0, 2, which is right there. Reflect it over to the other side. Now this is where you got to be a little bit careful. I'm going 7.5 to here, so I got to go 7.5 more, which puts me at 15, negative 15. Right here. So this is 0, 2. This is negative 15. Whoop, negative 15, 2. So there's 2 points. Finally, I can find one more point. Now in this case, I'd probably want to pick something in between here. Okay, so maybe I want to try negative 3. Substituting negative 3 in there. If I substitute negative 3 into this equation, I get 14. You can check the calculation using your calculator, but I get negative 3, 14. Here's 10. Be right here. I reflect that over to the other side. That's where you got to be a little careful. How far am I away from the line of symmetry here? About 4.5, so I got to go another 4.5, which would put me right here, which would be negative 12, 14. Okay, so now I've got my 5 points. Plot my graph, and you've got it. Okay, so that's about as difficult as it gets due to the numbers, the fractions, and the bigger values you get. But I wanted to try that one. So what I'd like you to do is try to graph this one. And bring it to class tomorrow and show me what you got. Okay? So that's section 4.1 on graphing parabolas in standard form.